grade 12 learners, welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember grade 12s, we have our WhatsApp number. The number is 079 454 9535. You are more than welcome to send all your clarity seeking questions to that particular number, or any alternative solutions that you can share, you want to share with us. And then today we'll be looking at differential calculus and the integration of which is part of our paper 1 work. And then after the completion of the lesson, you will be able to, number 1, determine the average gradient of a curve between 2 points. Determine the gradient of a tangent to a graph, which is also the gradient to the graph at that particular point. And then you will be able to differentiate from first principle functions defined by f at x equal to k, f at x equal to ax, f at x equals to ax plus b. And then you will be also be able to use the rule of differentiation, and then we are deriving in terms of x, ax to the power n. Therefore your answer will be ax to the power n minus 1, for which n must be an element of all real numbers. And then you must be able to determine the equation of a tangent to a function. That means we are talking to the cubic function, and then sketch the graph of cubic polynomial functions. You must be able to analyze the information from a cubic function, and then you must be able to solve practical problems involving optimization and rate of change, including the calculus of motion. We are still on differential calculus, grade 12. And then under integration, you must be able to integrate the following forms of integrals using the following rules. We are having rule number 1 here, and then rule number 1 states that if you are integrating kxn in terms of x, the answer will be kxn plus 1 over the n plus 1. Remember to add your plus c, and then that n must be an element of real numbers, and n cannot be a negative 1, grade 12. And then now the second rule, we are talking to the integration of a fraction now, and then in this fraction we are having k over x. We are integrating in terms of x there, and then this, if it's a fraction, remember this can also be noted as integration of k x to the power negative 1 in terms of x. This is one and the same thing. This one is in exponential form, that one is written in a fraction form. It means one and the same thing. It's either, it can be given that way or this particular way. And if that is the case, grade 12, your answer after the integral, it will be k ln of x plus c, and then x must be greater than 0 for that one. And then the third rule, if you are integrating ka to the power n x, can you see that x is an exponent now there in terms of x? Then you are going to have exactly what you are having there on top as your answer there, and then below you'll be having the ln of a there. Okay, do not forget plus c to show that you have now integrated. And then with a must always be greater and equal to 0, meaning it must be positive or equals to a 0. And then k and a must always be an element of real numbers. And then you must be able to integrate polynomials consisting of terms like in the above forms. That means above integral rules that we have just clarified to you. And then you must be able to apply integration to determine the magnitude of an area included by a curve and the x-axis, or alternatively included by a curve, the x-axis, and the ordinate, of which is x equal to a and the x equals to b, where a and b are the element of integers. And then in this case, grade 12, where you are determining the magnitude of an area included by a curve, you will be given a sketch of that particular graph that you will be calculating the area below the graph. Right, and then this topic, these two topics, differential calculus and the integration, on your paper, 1 out of 150 marks, they worth 50 plus minus grade 12. That is a lot. So you need basically to give these two particular topics an attention in order to pass your paper 1. So under integration, I've already elaborated on the rules now, and then we are giving an alternative rules that are going with the initial 3 that we were having, and then we will still classify them as rule number 1, rule number 2, and rule number 3 there. So now you are having here, this one is when a coefficient is 1 there, integration of 1x to the power n, it will be x to the power n plus 1, n plus 1 plus c, n must not be equal to minus 1. Now we are changing this coefficient, can be any constant number now, but the rule is applied the same way grade 12. It's only that if you are having a constant number there that is greater than 1, therefore you start by writing that constant value, and then we can now integrate your x to the power n there, and also n must not be equals to a minus 1. Rule number 2 is that one of which we said it can be a fraction. If it's not it is not 1 over x, it can be x to the power minus 1. It means one and the same thing, grade 12. This notation can also be written in that particular format. And then your answer will be ln x plus c, where x must be greater than 0. Why? Because if your x here can be a 0, this one will be undefined. Remember, division by 0 is not allowed in mathematics. Your problem will be undefined if the denominator becomes a 0. That is why we are emphasizing that the x value must be greater than 0. This one application is the same. The only difference is that on the previous one, we are restricted numerator to 1, whereas this one is opening now to be any constant value there. And then if that is the case, you start by noting down the constant value, and then we can now integrate your fraction, of which it will be the ln of x plus c. Still x must be greater than 0, grade 12. And then the last third rule, and then in this case we are having a to the power x. As you can see that the coefficient of a is 1 there. We are integrating actually 1a to the power x in terms of x, and then now the answer will be whatever you are having there will be on top. Only if your x is an exponent, that is how you integrate. And then over the ln of a plus c, and then a must be greater than 0 also in this particular case. And then now the difference between the two is that now here, remember, we are having coefficient 1. On this one, it is opening k to be any value there. And then now we are still differentiating a to the power nx now, also allowing the coefficient of your exponent to be any number, as you can see, and n is added there. And then now when you integrate this, you start by writing the constant value that you have there. Whatever you have next to your coefficient goes on top, and then on the denominator you are having the n ln of a there. And then that is plus c to show that you have integrated, and then a must be greater than 0. So we are elaborating more on the rules of integration, but at the back of your question paper you will be having the 3 basics ones that we talked to initially. And then now with differential calculus, we will be mostly focusing, the only formula that we have basically grade 12 is the first principle one on your formula sheet, of which states that the f derivative of x is equal to the limit of h approaching 0 of f at x plus h minus f at x over h. This formula, you will get it at the back of your question paper on your information sheet. Please use that information sheet effectively. So And then now we are now in differential calculus. We are going to look at first principle, that is the first subtopic there, and then we will be unfolding different types of questions on how do they ask this particular question now on your exams. And then the first activity here states that determine the derivative of f at x by using first principle if f at x is equals to 8. And then if you look at the formula of finding the differentiating derivative of f at x, you can see that you need an f at x plus h, because f at x is the one that is given to you there. And then now you'll simplify by dividing by h towards your answer there, grade 12. Let's see now. In this case, you have only f at x, which is equals to 8. That simply means this is f at x equal to 8x to the power 0. Remember, x to the power 0 is a 1. So this is the same as 8 into 1, of which is equals to 8. That is why they only write the 8 there. Okay. So basically now, grade 12, you now know there's an x to the power 0 next to that 8. And then now let's see now what happens when we try to find the f at x plus h, because our equation needs that. This will be f at x plus h equals to 8. For x, we substitute x plus h and then to the power 0. That simply means now we are now substituting x plus h in all the places where we see an x there. But look at this, grade 12s now. It will be 8. Remember, any number raised to the power 0, it's a 1. Exponent 0, it's a 1. So that x plus h, since the exponent is 0 there, it will give us a 1. So basically, our f at x plus h, it is also equals to an 8. It's the same. F at x equal to 8, and the f at x plus h is also equals to 8. This will be the condition, grade 12, where you are given your f at x as being a constant value there. Your f at x will be the same as your f at x plus h. And then now, after calculating these two now, we can now go into our formula. F derivative of x equals to the limit of h approaching 0 of f at x plus h. Let's substitute now. What is f at x plus h? That is 8 minus the f at x, which is also an h, divided by the h on the denominator there. Let's simplify. We are still having our limit of h approaching 0 there. So 8 minus 8 will be a 0, and then over h. So we are having the limit of h approaching 0 of 0 divided by h, of which is a 0. So the limit of h approaching 0 of a 0, therefore it will give us an answer of a 0. This is basically telling us that grade 12, that when you are differentiating a constant number, your derivative will be equals to 0 there. And then let's look at the allocation of marks. 1 mark will be for the correct f at x plus h, 2nd mark for substitution, the 3rd mark for simplifying, and the 4th one for the final answer. For this type of question under first principle, this will worth 4 marks. And then look at activity number 2. Now we are still on first principle. We are determining the derivative of f at x equal to half pi now. Okay, this is half pi. Grade 12, remember, pi is a constant number. It's not a variable. It is representing approximately 22 over 7, or approximately 3,14 value. It's a number. Therefore, a half of a number, the answer will still be a number. It's like we are having a constant value like in the previous question. So that means in this case, we are also having that x to the power 0 there. And then this will be f at x plus h. For x and x, we are going to substitute x plus h. We are having half pi, and then for x is x plus h to the power 0. And then now this will be half pi, x plus h to the power 0 is 1. So we are still having that half pi as our f at x plus h, of which is the same as our original f at x, of which is half pi there. So now we have f at x, we have our f at x plus h, then we can substitute in our derivative formula. F at x is equals to the limit of h approaching 0 of f at x plus h, grade 12. You must rewrite the formula, although it is on your formula sheet. You must take it out of that formula sheet into your answer sheet. There we have plugged the formula. After plugging the formula, you can now start substituting into the formula correctly. So f at x plus h is that value there, half pi minus the f at x, which is still a half pi. Can you see, grade 12? We are subtracting same terms there. Why? Because our f at x is a constant value there. And then we are having the limit of h approaching 0. Half pi minus half pi will be 0 over h. And then this is the limit of h approaching 0 of 0 over h, of which is still a 0. So if the limit of h approaches 0 of 0, the answer will be 0 there. So that is our f at x derivative there. Okay, the location of marks still the same. It's one for correct f at x plus h, second one for substitution, the third one for simplifying, the fourth one for the final answer for this type of first principle. Third activity now, determine the derivative. We are still on first principle, but look at this one now. It is no more a constant. We have started with a constant. This one is having an x. It's minus 5x to the power 1 now. It's not to the power 0 as the previous one. And then if this is the case, grade 12, your answer is already there for you. Your answer is on the given f at x. That means the coefficient of your x there will be your answer. After solving this, we are expecting your answer to be a minus 5. Let's see. According to the first principle formula, we need f at x plus h. So where we have an x, we are going to substitute that with x plus h. Let's do so, grade 12. We are having f at x plus h equals to minus 5. For x, we substitute x plus h. And then if we simplify this, minus 5 times x is minus 5x. Minus 5 times h minus 5h. We are simply distributing the minus 5 into the bracket. So this will be our f at x plus h. Then we can now substitute into the first principle formula. It states that the derivative of x of f at x is equal to the limit of h approaching 0 of f at x plus h minus f at x over h. You continue writing your limit of h, grade 12. You'll stop only on the final answer. Limit of h approaching 0. F at x plus h is this answer that we have there, minus 5x minus 5h, minus, you need to put a bracket there. Why? Because you are having a negative from the formula, and then your f at x is coming with another negative there. Then it will be minus negative 5x there. That bracket is very important, grade 12. And then over h. And then after this step now, you need to remove the brackets there. By distributive law is minus 5x minus 5h, a negative times a negative there. Remember there's a 1 there. It's a negative 1 actually there. So it's minus 1 times negative 5, which is positive 5x all over h. After removing the brackets, simplifying the brackets, grade 12, whatever was your f at x here must disappear. If it doesn't disappear, that means you made something wrong somewhere. Go and check back. So now we are having minus 5x plus 5x, of which is a 0. So we are left with what, grade 12? Limit of h approaching 0 minus 5h over h. The h goes once into h there. And then we are left with the limit of h approaching 0 of minus 5. Therefore, Look at the answer now. When you write an answer, you write only -5. You don't write a limit anymore there. So your limit disappears on your final answer, grade 12. Only on your final answer. And then these types of first principle, they worth 5 marks. Check all your papers. And then the first mark will be for f at x plus h. Second mark for substituting into the correct formula correctly so. And then the third mark will be for simplifying. The fourth mark for cancellation of the h. And the last mark will be for the final answer. Therefore, this is worth 5 marks. Okay. And then now, grade 12s, I am giving you 2 minutes to try this one on your own so that we can see whether can you manage to master this on your own. Your 2 minutes starts now. Okay, grade 12, let's check now how far did it go. Remember to send your clarity seeking question to our WhatsApp number 079 454 9535. Okay, now do you still remember the method now? Firstly, identify your answer. What is your answer? It must always be the coefficient of x, and then in this case is 0,5. That is the expectation. And then now when you look at the formula, you need f at x plus h. Therefore, you are going to look at the f at x plus h by substituting wherever you have an x by x plus h. Then this will be 0,5 into x plus h plus 5. And then now we multiply by distributive law 0,5 in. It will be 0,5x. And then 0,5 times h plus 0,5h. And then this 0,5 is not affecting a 5 because that 5 is not part of the bracket. So it will remain plus 5 there. You cannot grade 12 multiply 0,5 to that one because this 5 is not inside the bracket. So that is our f at x plus h then. And then from there we move to the f derivative of x formula of first principle, the limit of h approaching 0 of f at x plus h minus f at x all over h, continue, limit of h approaching 0. F at x plus h is the answer that we have identified there, 0,5x plus 0,5h plus 5 minus, remember the important bracket there, before you write your f at x please bring in the bracket 0,5x plus 5 into close bracket there, divide by h, and then now we have a limit of h approaching 0, and then this will be 0,5 x plus 0,5 h plus 5. The aim is to get rid of the bracket here. This will be negative 1 times 0,5, which is negative 0,5x. Negative 1 times 5, that is negative 5, all over h. And then from here, look at this. Remember, I said to you, whatever was your f at x initially at this level, there must be some subtraction and cancellation. Then 0,5 minus 0,5, 0, 0, and then 5 minus 5 give us a 0. So we are left with what, grade 12? The limit of h approaching 0 of what? 0,5 over h, 0,5 h over h. And then from this step, h goes once into h there. What is left is the limit of h approaching 0 of 0,5. And then now your answer is not having a limit, grade 12. It's only your 0,5. Is it true according to what we predicted, that our answer will be the coefficient? Yes, that is exactly the same, of which is 100% true. So that is the testing, grade 12, of the answer. So now you are guided to the correct answer there. And then mark allocation, f at x plus h, substitution, simplification, h, and then the final answer there for the problem is worth 5 marks. And then now we move to the second subtopics, where we are applying the rules of differentiation now. That will be the question after the first principle on your calculus. And then we are having rules that we are following when we are differentiating using the rules. And then rule number 1 states that if f at x is equal to a, remember a is a constant value there, as we have indicated on our first activity, that when you derive a constant, the answer becomes 0. So the same applies with the rules now. If this value is a constant value, its derivative will be equals to 0. That is the rule. And then if it is f at x equal to ax, then the derivative will be coefficient of a. That is what we have done, but using the first principle. So what do they mean in this case here? It's when maybe we are given f at x is equal to 2x. Therefore, your f derivative of x for that one will be that positive 2. That is the front part there. That is what we mean about this particular rule there. Can you see the same? Okay, and then rule number 3, we are given f at x is equal to ax to the power n. Now, can you see now in this one, exponent of x was x to the power 1. In this case, n can be any value bigger than 1. Okay, so that means now if that is the case, the rule states that you take the exponent, you multiply it by a. That is what is happening here. And then from your exponent, you subtract 1. That is what is exactly happening. So what does that mean now? It means if I am having the f at x equal to 10x to the power 2, this rule states that I have to multiply 10 times 2 to get an answer for the derivative of that. That will be 10 times 2x, and then exponent 2, I must subtract 1. That is the application of that rule. Then it will be 10 times 2, which is 20x to the power 1 there. So that is the derivative of this value here. Now, before we start deriving, we must be careful about the notation now. Sometimes your equation will be given in terms of f at x as they have elaborated there on your rules. If that is the case, now when you derive, we must see this dash here to show that you are now deriving. And then if it is given as an equation of y equals to, then we must see a dy dx that you are now deriving, grade 12. If it is given in terms of dx, now as you derive, that dx must disappear. We must see only your derived values there. This applies on also if we are having or the d over dx. Already your expression is given as dx, and so for then you need to write it without that dx when you give a derived answer. Then before we derive, there are things that we need to look into, grade 12. Number one, you must ensure that if we are having brackets, you must simplify those brackets thoroughly. So for an example, if I'm given d at x, I need to derive x minus 1 squared there. This is what we are talking to when we say simplify brackets as far as possible. You cannot derive this. You must continue writing dx and deal with this bracket now, because it says 2 bracket of x minus 1. So it will be square the first term, multiply the first by the second by 2, that is minus 2x, and then square the last term, that is positive 1. And then you can now start deriving. So this notation is saying when you start deriving, you just put an equal sign, the dx will disappear. Then it will be 2 times 1, that is 2x minus 1 to the power 1. The rule number 2 states that if it is to the power 1, you take the coefficient, that is minus 2. Rule number 1 says if it's a constant, the answer is 0. So we are basically having a plus 0, of which you don't even write it there. So that is what we mean about this notation. And then now, secondly, you must check that you do not have variable on the denominator. For example, if you can have 2 over x here, there's no way you can derive this grade 12. You must write it first as 2x to the power minus 1. You take this x on top, no variables on the denominator. It's only then that we can say now we are deriving dy dx. This will be minus 2x to the power minus 2. It's an exponent, multiply by 2 minus 2, subtract 1, that is to the power minus 2. So guard against the variable on the denominator. Lastly, we must not have the root sign on your expressions. For an example, let's say we are having f at x is equal to the cube root of x squared there. You cannot derive if we are having a problem like that one. So the first thing that you need to do, you need to write this in exponential form. So we have x squared there, then this cube root will be over 3 when it comes to an exponent there. Can you see it goes below the exponent that is already there? Then it's only here, grade 12, that you can start deriving. And then we have cases like where you are having maybe your f at x being x squared minus 4 over x minus 2. And then now you need to factorize the top part because it's difference of 2 squares. It will be x minus 2 and x plus 2 there. And then over x minus 2. So that means fractions, you need to simplify them as far as possible before you derive. Can you see the x minus 2 will cancel that? That means we are basically deriving x plus 1. So the derivative of that will be equal to 1. So that is what we mean, grade 12. You take care of these conditions, 4 conditions, before you start applying the rules of differentiation, and then now ensure that the notation is correct. If the incorrect notation is picked up, you will be penalized once out of your whole paper 1. There will be a penalty for incorrect notation, grade 12. 1 mark will be taken for incorrect notation. Right, let's look at the activity now. Remember your rules. If it's a constant, it's 0. If it's x to the power 1, you take the coefficient. And thirdly, if the exponent is more than 1, then it's exponent multiplied by coefficient, subtract 1 from the exponent. Those are the rules of differentiation. And then now, let's determine this one. Remember, a pi is a constant value. It's like having a 2 or a 3, because pi represents approximately 22 over 7 or the 3,1 form in decimal form. So now, if it's a constant value, rule number 1 states that your answer will be 0. Do you still remember that, grade 12? That means for this one, since there's a notation there, you need to start deriving and giving the solution. This d at x will disappear. That is why this problem is only 1 mark, because the answer is 0. Why? Because we are deriving a constant value there. And then if you look at this, we are having rule number 2 and rule number 3 here. We have all of them actual, 1, 2, 3. Because this one is a constant value, this one is x to the power 1, this one is x with an exponent more than 1. So now we check, we don't have fractions, we don't have variables in the denominator, we don't have a root sign, we don't have fractions to simplify, we don't have brackets. That means now we can go straight deriving. That will be f derivative of x, of which 2 times 1 here, it will be a 2, x to the power, exponent be minus 1, 2 minus 1 will be 1. This one, since it's x to the power 1, rule number 2 says take the coefficient, it will be plus 3. Minus 7 pi is a constant value, therefore derivative is 0 there. That is why it's 2 marks, it's 1 for 2x and 1 for 3. If your notation is wrong, 1 mark will be taken grade 12 from your 2 marks there. And then question number 3, we are determining dx of x minus 2 bracket squared. Can you see that? We cannot derive. Why? Because there are brackets that need to be simplified. And then notation, this notation, because we have not yet started deriving, we'll leave it as dx there. And then we are multiplying 2 bracket of x minus 2 there. And then now this will be dx into x squared minus 4x plus 4. Remember, it's an x by x, x squared, x by minus 2, minus 2x, minus 2 times x, minus 2x. So a minus 2 give us this minus 4 in the middle there. And then minus 2 times minus 2 is a positive 4. Okay, or you can use my short method. You square the first term, that is the x squared. You multiply the first by the second term, multiply by exponent, that is minus 4x, the middle term. You square the last term, minus 2 squared is a positive 4. That will also assist in getting the correct answer for those brackets. Then after removing the brackets, we can now start deriving. The minute I start deriving, therefore this dx notation will disappear. I will just give my answer as 2x minus 4. Then the first mark will be simplifying bracket, and then for the correct derivative with correct notation there for grade 12. And then now let's look at number 4 under rules of differentiation. Determine dx of x to the power 4 minus cube root of x. We have a challenge now because we have a cube root there. We can't derive with the root signs, okay? Sets or root sign we can't derive with that. So still we need to simplify this. It will be dx x to the power 4 minus, remember there's a 1 here, exponent 1. It will be x to the power 1, and then this 3 will join the denominator exponent there. So that is the dx we are having. And then now, can we derive? Yes, we are having dx will disappear, and then it will be 4 times 1, which is 4x, 4 minus 1 to the power 3. 1/3 times negative 1 is negative 1/3, and then from 1/3 we subtract 1, that will be x to the power minus 2 over 3. So it's the first mark for getting rid of the root sign, of the cube root sign, and then the second mark for the derivative, and the third mark for the correct derivative, the grade 12. Right. And then with number 5 now, we are having determine dy dx if y is equal to that fraction that is given there. We cannot derive. Why? We have a variable in the denominator, so we cannot derive. So we need to simplify that fraction first before we apply derivative. Let's do so, grade 12. We are having y is equal to, how are we going to do that? Each and every term is going to take this denominator now. We will be having x squared over x plus 2x over x minus 5 over x. And then we are still on y equals to, because we are busy simplifying, we have not yet started deriving, we will continue writing y. And then now x squared divided by x, division of same base, you subtract exponent, therefore it will be 2 minus 1, which is x to the power 1. Or you are saying on top you have 2 x's and then denominator 1. So 1 will cancel, will go 1 into 1, and then you'll be left with only 1 x there. So now with this one is plus, and x goes once there, you are left with 2. Remember, we cannot derive with the denominator variable on the denominator, so we are taking this x to join 5 on top. It will be minus 5x to the power negative 1. Happy now, everything is on the same line. It's only then that grade 12 you can derive. Therefore, because we are now starting deriving, we will indicate by noting now dy dx. That means you are informing us that I am now deriving. Okay. And then now, remember, if it is to the power x to the power 1, you take the coefficient. Therefore, derivative of that will be 1. This one, rule number 1, is a constant value. The answer will be 0. And then the last one is minus 1 times minus 5. That is plus 5. Exponent minus 1 will be minus 2. Therefore, the derivative of this is 1 plus 5x to the power minus 2. So the first mark will be writing this as a simplified fraction, and then second mark for first derivative, and then the second one. Therefore, this will be worth 3 marks, grade 12. And then now number 6, dy dx if y is equals to, can you see again, we have a challenge of a denominator there that is having an x. We can't derive with that. So now this will be, because we are busy simplifying now, we are going to, grade 12, do not confuse this. On the previous one, we are having a single term on the denominator. That is why it was easy to share it amongst all the numerator values. In this case, we have a binomial. We have 2 terms on the denominator. There's no way that we can share amongst the numerator. So in this case, where we are having more than 1 term in the denominator, there must be some factorization involved there. That means now if you look at the top, you can see that you have factorization of difference of 2 squares. Therefore, we will be having bracket of difference of 2 squares, of which is x. This we are having 2 x's here. We will be sharing them equally. And then now it's like we are looking at the square root of each here. Okay, square root of x squared you share equally, and then square root of 4 is 2. Then this will be 2 and 2 there. The other bracket will be negative minus, and the other one will be a plus, because we are factorizing difference of 2 squares. And when you multiply them back, grade 12, they must be able to give you that x squared minus 4, if you are 100% correct. And then denominator x minus 2. Now, can you see now? We have something in common there. Then it will go 1, 1. Then you are left with y equal to x plus 2. Yes, we have simplified this. It is no more a fraction. We can now derive. And then remember, this is to the power 1. Rule number 2 states that you take the coefficient there. Notation is dy dx, and the answer is 1. 2 is a constant value, rule number 1. Therefore, it will give us a derivative of 0 there. Okay. Move on to number 7. Move on to number 7. With number 7, we are given that dy dx if xy is equal to 7, square root of x equals to 3. But you are controlled by the message here. It is saying derive y in terms of x. So we cannot derive this when it says xy equal to 7 square root of x there. We must have a y equals to something. So we are going to divide both sides by x, so that we can have a y equal to 7. This is x to the power what, grade 12? Remember, there's a 2 there, of which you don't normally write, but that is the square root, okay? And then over x there. Then it's y equal to 7, base x. Remember, division of the same base, you subtract exponent, half minus 1 will be minus half here. Can you see that now? It's on the straight line. We can now start deriving. That is dy dx is equal to negative half times 7. That is negative 7 over 2. X on the exponent you subtract 1. That will be minus 1.5, of which is minus 3 over 2. Therefore, that is your derivative, great child. Your first mark is for writing this equation with y equals to, all right, for dividing by x both sides. Number 2, for writing the square root of x as x to the power half. That is your second mark. The last mark will be for the correct derivative there. Therefore, this problem with 3 marks, great terms. Now we are done with the rules. We can now move to the equation of a tangent. We are still on the differential calculus. And then remember now, when you talk of the equation of a tangent is a straight line. Remember, it's a line that touches a curve at one point. Okay, so equation of a tangent, we are basically looking for the equation of the straight line y mx plus c, or it can be written as y minus y1 equal to m into x minus x1. And we know, grade 12, in order to find this equation, you must have a gradient and a point. Then you will be able to find the equation of a tangent. If you don't have a gradient, and then in this case now, because you are on calculus, we are not using that change in y over change in x is equal to, we will be relying on the derivative of a function that is a tangent to, in order to find this m. So it's a derivative m of a tangent. We'll be looking at the derivative of the function that we will be looking into in order to find the gradient of a tangent. Let's see, how do we apply that? The first one, activity there, it says given g(x) is equal to 3x squared plus 9x. That is the function given to us. And then the first question, it says determine the derivative of g at x. Can you see that? They say derive g at x for 2 marks. So now we apply the rules. Now we are no more using first principle. First principle, it will be written. Use first principle to do this. Then you follow first principle. If it's not indicated, you use your rules, great child. Therefore, g derivative, let's apply the rules. That is 3 times 2, 6x. From exponent, we subtract 1 to the power 1. Rule number 2 now, if it is to the power x, you take your coefficient as your derivative there. So basically, that is the derivative that is worth 2 marks there. That is the derivative of your function there. And then now, 1.2, we are still on g at x function. They say determine the gradient of a tangent to the curve of g at the point where x is equal to minus 3. Remember, we have already derived the g function and ended up with the equation 6x plus 9. But now, they say we must look at that gradient of a tangent at the point where x is equal to minus 3. So we are going to substitute our x with the minus 3 because it's given as being minus 3 there. That will be 6 into minus 3 plus 9. And then the minute you are looking at the gradient at a certain point, this is now a gradient of a tangent. Looking at the derivative at a certain point of contact, therefore we are basically looking for the gradient of that particular line there. And then now they say 6, 12, 18, that will be minus 18 here, plus 9, therefore our gradient will be minus 9, grade 12. Gradient of that tangent is negative 9. That means it's a decreasing function because the gradient is negative. So this is the line we are expecting with the negative gradient there. Okay. Moving forward, hence determine the equation of the tangents to the curve of g where x is equal to minus 3. Remember, we have already calculated the gradient of this g at x function, and then we ended up with -9 as being our gradient from the previous question. And then now they say determine the equation of that particular tangent. And a tangent, remember, it's a straight line, y mx plus c, or you can use y minus y1 into m equal to m into x minus x1. We indicated earlier that if we can have a gradient and a point, we can be able to find this equation. So happy, now we have a gradient, and to our point we only have the value of x, which is -3. But grade 12, if you are having the value of x and the equation of a function, you can calculate the value of y for that particular function. That is exactly the route that you will be taking now. To find the value of y, we are going to substitute this -3 into the equations. Original, not the derivative one, g into -3 is equal to 3 into -3 squared plus 9 into a -3 into the original. The minute you substitute into the integrated one, you are looking for the gradient now. But here we are looking for the coordinate, y coordinate of -3. So that means now here we are basically looking for the y value at x equal to -3. And then this will be 3 times 3 squared, that is a 9. 9 times 3, 9, 18, 21. And then 9 times 3, it is also minus a 21. That means y will be 0 there. So this p is at -3 and 0 there. Okay, remember this is -3 squared, which is 9. 9 times 3 is 21. It's the same as 9 times -3 minus 21. Now we have a point which is -3 and 0. So happy grade 12, you have your x, you have your y, you have your gradient. Then you can go into that original straight line equation, mx plus c. Then what is the y value? 0. The gradient -9. The x value -3 plus c. Then it's a 0. And then negative times negative is a positive. 19, 9, 18, 21 plus c. Therefore the c will be -21 there. Then we can now have the final equation of this particular tangent. Now remember, when we need an equation, we leave y and x for the final answer. Now gradient -9x, and then the c value is -21. That is how you find this equation. So the first mark is for finding the value of, that is 4 marks, is for substituting -3, getting the value of y, substituting your gradient and -3 and 0 point, and then now the final equation there. Therefore this is worth 4 marks, grade 12. And then the next question, now we are still on the equation of a tangent. Now let's see on this one what is expected from you, grade 12. We are giving a different way of asking the equation of the tangent, now trying to unfold different types to you. In this case, they say determine the point of contact between a tangent. That tangent is having a gradient of 8 and the curve of f at x equal to 4x squared minus 1. That means we are having a parabola function, f at x equal to 4x squared minus 1. And then this graph is turning at 0 and -1 there, something like that. And then it's either we are having a tangent this side, we are not sure, or the gradient is 8, therefore it's a positive one, it's an increasing one, it can't be there. It's only this one. Why? Because the gradient is positive. It must be an increasing function. So it touches this graph at a point of contact, 1 point there. They say determine the coordinates of this point of contact. What is x and then what is y there. So what we are going to use, grade 12, is this gradient that is given to us. And we know that the gradient of a tangent, we get it by deriving the original equation, of which is a tangent at a point of contact. So we are going to derive this f at x, because by deriving we are now looking at the gradient of a tangent at point of contact. Then this will give us 4 times 2, which is 8x, minus 1 is a constant value, the derivative is 0. And then they say, now remember, this is a gradient of tangent at 8x, right? But in this case, the gradient is given to us, that this is equals to 8. Divide by 8 both sides, therefore we end up with x equal to 1. That means this is a tangent at a parabola at x equal to 1 there. That is the first value, of which is our x value. And then to get the y value, we are going to substitute this x into the original equation. Look at f at 1. 4 into 1 squared minus 1. Therefore, our y value will be 4 times 1, which is 4 minus 1, 3. Therefore, the coordinates determine the point of contact of tangent. That point of contact will be having the coordinates 1 and 3. So that is how you identify the point of contact. And then let's see, mark allocation is for derivative number 1, for equating your derivative to 8, for finding the value of x, for substituting 1, for finding the value of y, and then for writing that in coordinate form. Right, and then we are done with the equation of a tangent, grade 12. We have tried our level best to unfold different ways of asking it. And then now we look at the cubic function. So cubic function is the original, is the graph of the calculus, and then with the original equation y is equal to ax cubed to the power 3 plus bx squared plus cx plus d. So that is the original equation of a cubic function. And then now let's see now. The first activity, you are given a function defined by f at x equal to minus x, bracket x minus 3 and x minus 3. Can you see this bracket are repeating? The minute they are repeating, that means it is one of the stationary points, turning point. And then now, question, write down the coordinates of the y-intercept of f. By say write down, that means the answer is already on your given information. You are not calculating, but you are writing down the coordinates of the y-intercept. Remember, to find the y-intercept, you let x equal to 0. If you put 0 here, 0 here, 0 here, can you see we are multiplying the whole thing by 0? Therefore, our answer will be 0. So now our y here will be equal to 0 when x is equal to 0. So the coordinate will be 0 and 0 there, because they are looking for the coordinates. It must be written in coordinate form. That is your 1 mark. And then 1.2, write down the coordinates of the x. Again, they say write down. There are no calculations, therefore answers are on your given statement. Because if you look at this f at x, they have already factorized for you. So now if we let this equal to 0, because when you calculate the x-intercept, you let y equal to 0. So your first x value there will be equal to 0, or the second one will be x equal to 3. Because this is the same, you can't repeat. You will be only having those two. That means that is why we have 2 marks there. And then if they say write it in coordinate form, that remember to get the x-intercept, we let y equal to 0. That means for the first x value, y is 0. And also for the second x value 3, your y is 0, because they need the answers in coordinate form. Always be safe, grade 12, write it up to the coordinate form so that you can always get your full marks. And then you are given a function, we are still on f at x. They say show that this f at x can be written in this format. It's the same thing. What do they mean, grade 12? They only mean that multiply your brackets out. Okay, now let's do so. We are having f at x equal to minus x, and then you are going to multiply these two. It will be x times x, which is x squared, and then x times minus 3 is minus 3x, minus 3 times x minus 3x, minus 3x plus minus 3 is minus 6x, minus 3 times minus 3 is positive 9 there. We are not yet done, grade 12. We still have to multiply the minus x in distributive law. A negative x times x squared is a negative x cubed. Can you see that? It's correct. And then negative x times minus 6x is a positive 6x squared. Correct? Can you see that? And then the last one, minus x times 9 is minus 9x. Exactly the same as the expected formula there. So the first one will be the first multiplication of bracket, and then the second one will be for the final correct answer there. Correct multiplication, grade 12. And then 1.4, determine the coordinates of the turning point. We are still on the same f at x function. Remember, we have just indicated that on 1.3 that f at x is the same as minus x cubed plus 6x squared minus 9x. So we are talking to the same function then. Why are we bringing this now, grade 12? You cannot find a turning point when this is in the form of brackets, because you need to derive. The rules of differentiation, it says the rules of differentiation, yes, it states that you cannot derive when you have brackets. You need to multiply them out and simplify. That is exactly what is happening here. And then now, let's start by deriving now. We can now derive. This will be 3 times 1 minus 3x, subtract 1 to the power 2. 2 times 6, that is 12, subtract 1, x to the power 1. This is x to the power 1, we take only the coefficient as being the derivative. Then we have our derivative. Because we are looking for turning point or stationary point, we let this derivative be equal to 0 because the function is stationary there. And then this will be equal to this side. We are dividing by minus 3 throughout. And then that will be x squared minus 4x plus 3. And then 0, we are factorizing this. We are looking for factors of 3. When you add them, you get 4. Okay? Factors of 3, when you add them, you get a 4. That is 3 and 1. And then in order to be minus 4, they must both be negative. So the first bracket is giving us the x value that is equals to 3, or the x value that is equals to 1. And then these are only x turning points, grade 12. Remember, they need coordinates of the turning point. They need both x and y. So we are going to substitute the first x value there, x equal to 3, into the original equation there. And then when you do so, we will be looking for the y value for that particular function. So that y is equal to minus 3. We are now substituting 3 minus 3, 3 minus 3. This will be 0, and 0 multiplied by 3 will give us a 0 there. Therefore, if x is 3, y will be equal to 0 there. Can you see it is bringing a turning point that is the same as the x-intercept there? Okay? And then now to find the y turning point for y, we are having for y, x equal to 1 is minus 1, 1 minus 3, 1 minus 3. We are now substituting x with the 1. And then that will give us a minus 1 into minus 2, minus 2. Negative 2 times negative 2 is a 4 times negative 1. It's a negative 4. Therefore, this one coordinates with a negative 4. And then if you write in coordinate form, it will be 3 and 0, your first turning point. Second one will be 1 and -4. And then grade 12, now at this point, please ensure that you already identify which one is the maximum turning point and which one is the minimum turning point. How do you do that? You look at the y values now. The bigger one will be maximum, the smaller one will be minimum. Y values, okay? So we compare 0 and -4. Which one is bigger? 0. Therefore, it will be maximum, your graph at 0. And then it will be minimum at -4 there. This will assist you when you sketch your graph. Okay. And then now, the next question, you need to sketch that function. Remember, when you sketch a cubic function, you need to know your shape. How is your shape going to be? Now, we are looking at the value of a there. A is less than 0, meaning is negative. So we are expecting a graph that will end up being concave down, starting being concave up, ending with concave down. And then now y-intercept we have calculated previously, and then we ended up with y equal to 0. And also the x-intercept we have calculated on the previous questions, and then we ended up with x equal to 0 or the x equal to 3. And then now we have just calculated the turning points for this graph. We have just calculated that the first one will be 3 and 0, of which is the maximum one. The second one will be 1 and -4, of which will be our minimum turning point. With this information, grade 12, you can now sketch your graph. Okay, now let's start now. Y-intercept at 0, and then now the x-intercept again at 0, and then x-intercept again at 3. Another x-intercept is here at 3, and then the turning point, the first one is 3 and 0, and then it's a maximum 1. I'm indicating as maximum as indicated there. And then the other turning point is at 1 and -4, -1, -2, -3, -4. Then this is coordinating because it's a turning point. Then we'll be having a turning point there, of which it's a minimum 1. So now we can now join our points, grade 12's turning point there, and then this will go and cut at the x-axis there at 0. So this is basically the graph of f that we have just drawn there. Okay, it is passing x-intercept 0 and 3 and y-intercept 0. And then now those are the turning point 3 and 0 and 1 and -4. And then the mark allocation for this is for the shape, for the intercept, for the stationary point of that particular graph. There's no way it can be 2 marks, grade 12. There will be mark for the shape, mark for both x-intercept, mark for y-intercept, and then mark for the turning point. So this graph is worth 4 marks. Okay. And then now they say use the graph that we have drawn. Use the graph of f to write the values of x, for which when you multiply your x-axis with your function, with the derivative, it must be derivative there. It must be less than 0. Okay, they say use the graph. Let's bring our graph here that we have just drawn above. It is turning at 3 there. So we have 3 here, we have 1 and -4, and then it's passing through 0 there. This is the rough sketch of the f function that we have just drawn above. And then now they say out of this we need to understand what do they need there. They say take the x-axis of your graph, this line here. And then when you multiply that with the gradient of that graph, your answer must be less than 0. Less than 0 means the answer must be negative. And then in order to get a product that is giving you a negative answer, you must be multiplying a negative times a positive or a positive times a negative. So either the x must be negative, therefore the derivative positive. Okay, we now understand we are looking for two different signs in order to get a negative product. So we go to the graph now. The x-axis, we know this side we are having positive x-axis. On the left hand side here we are having the negative x-axis. And then now we need to identify the gradient now of the graph. Remember, gradient talks to the decreasing and increasing. If it is decreasing, it's a negative gradient. When you decrease something, you subtract it. Therefore, decrease is a negative gradient. And then when it increases, it's a positive gradient. When you increase something, you add. Therefore, it's an increasing. And then it will decrease again because it's a cubic function. So in this case, since it is decreasing this side from left to right, therefore it will be a negative gradient. We exclude stationary point there because the graph is stationary. Immediately after stationary, the graph is positive because it is increasing. Gradient is positive. At stationary, it is stationary there. And then it goes down, it is decreasing. And then now, grade 12, I want us to identify where we have a negative by positive or a positive by negative now. If you look at the left-hand side of your Cartesian plane, and then these graphs are negative, both of them there. We can't take that solution because we are looking for negative and positive. So immediately up to this point here, can you see we are having negatives and positives here? So that means this is our first solution here. Okay, and then between this interval we can't take anything because it's positive. We are not looking for that one. And then this side after 3 here, stationary, can you see we have a positive and a negative? That means this is our solution up to infinity because this is continuing. After identifying that, grade 12, it's only then that you can give us the solution. Oh, the first one will be between these x values here. That means the first one will be between what? A 0 and 1. That is the first solution. Or second one will be x greater than, going this way, greater than 3. That is the solution. So the marks here must be 3 marks. It's 1 for the notation and the critical value. Notation and critical value, and the third one is for the H1. Okay, so that is how you answer or identify those solutions, grade 12. And then now 1.7, for which values of x will the graph of f be increasing? Remember, we have already identified the increasing and the decreasing part. Here we have our graph again. I am bringing it back. So stationary here is 1, and then here it is stationary at x equal to 3. Intercept is 0 then, and -4 coordinate there. And then we want where the graph is increasing and decreasing. So remember, here is a decrease. From left to right, the graph is decreasing and becoming stationary. And then from here it starts increasing, becomes stationary. After stationary it is decreasing. Can you see that? Now we can now identify this graph is increasing from where? From this point up to that one. So we are having a cut off here. So this is the position where we are having the increase. And then this one is the decrease, and this side is also a decrease. So for increase, first solution there, that means our x must be between 3 and 1. That is the increasing position. And then for the decreasing one is from this point to negative infinity. That means it's x less than 1. Or from this point here up to positive infinity. That means at x greater than 3. Those are the two solutions. So this will worth 2 marks, and also this 2 marks. Critical inequality sign with correct critical values there. Inequality sign must be correct, and the critical values must also be correct. And then now let's interpret a cubic function now. Remember, we are sketching and analyzing questions based on the given formula. Here we are given a graph. The graph shows a cubic function defined by h at x is equal to x cubed plus px squared plus 9x minus 2. And then it cuts x-axis at a. We have an a there. And then b here with coordinates 2 and 0. And then we have c there. And then we have D and E as being the turning point of that particular graph. And then we have F as the y-intercept of the graph. And then they say write down the coordinates of F. Write down. No calculation, write down. We know that if you want y-intercept, you let x equal to 0. So if you put a 0 there, it will be 0, 0, 0. Can you see your y will be minus 2? That is why they say write down the coordinates of F. That will be x0 and y minus 2. So this is worth 2 marks, grade 12. And then 2.2, they say now show that p is minus 6. We now have F here as 0 and minus 2. And then now remember we are given b there as 2 and 0 also. Now they say show that p is equal to minus 6 now. So we are going to choose this point B. We can't use that one, grade 12, otherwise it will cancel everything. We are going to rely on B, 2 and 0 there. And we will substitute this as x and y in our equation so that we can find that value of P. So now we are having y is equal to x cubed plus px squared plus 9x minus 2. Then we are going to substitute a y with the 0 and then x with the 2. I am substituting. And then we leave a p. We are looking for that p. X is 2 squared plus 9 into 2 minus 2. And then let's simplify now. 0, 4 there. And then, oh, this is cubed. That is 8. Is 2 to the power 3. That is 8. And then 2 squared times p, that is 4p. 9 times 2, that is 18. And then minus 2. 0 equals to, you are adding like terms now. 8 plus 18, that is 26. 26 minus 2, that is 24 plus 4p. And then we transpose 4p to the left, or 24 to the left is minus 24 equals to 4p. Then we divide both sides by 4. Therefore, p is equals to how much, grade 12? 4, 8, 12, 16, 20, 24. That is 6 times. Therefore, p will be 6. Minus 6 as indicated there. So the first mark will be substitution of 2 and 0. And then the final mark for proving that p is equal to minus 6. At least that is a level of simplifying there. Then you'll be having your 2 marks, grade 12. Now, since we have proven that p is minus 6, we can now bring in that 6 into our equation and use it in that particular equation now. All right. And then for the next question now, determine the length of BC. We are looking at the length of B, of which is 2 and 0, and the point C there, from here to there. We can only do that if we can find the coordinates of C there. And C is the x-intercept of this exponential function. Okay, that means we must look for the x-intercept of this cubic function. Remember, p is minus 6x squared plus 9x minus 2. Basically, we already have one factor there, of which is x equal to 2. If we take this back, it was x minus 2 equal to 0. So we are having a factor. If we let that equal to 0 to solve for x, we have factor x minus 2. So we are looking for the trinomial factor. We'll say x cubed divided by x, that is an x squared. And then we don't know the middle term. And then the last term will be minus 2 divided by minus 2, that will be a plus 1. So we need to look for that value of b grade 12, then we will be able to factorize that trinomial bracket. And then now we are going to apply the method. We are going to apply the short method. They call it inspection method, but I prefer to say the short method of factorizing. You can use a synthetic division, you can use your long division, you can use any method that you are comfortable with, grade 12, to find the factors of this. And then now, if we look at that now, how to use the short method, we are going to multiply x times b, that is bx squared, minus 2 times x squared, that is minus 2x squared. And then after finding only those two, you are going to equalize it to the x squared on your expression, minus 6x squared. And then now the bx squared, we transpose minus 2x squared to the right hand side, it will be plus 2. And then minus 6 plus 2 is minus 4x squared. Therefore, b is equal to minus 4. So this trinomial, basically, it will be 0 equal to x minus 2. And our trinomial will now read my x squared minus 4x plus 1. So we are looking for factors of 1. When you multiply, you get a negative 4. There are no factors like that, grade 12. So we need to factorize this using a quadratic formula now. You will be having your first x value. Yes, x will be equal to 2 for that one. Happy, because you already have that. And then for this trinomial here, we are going to use the quadratic formula. X is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Then we substitute x is equal to minus 4 for b plus minus the square root of minus 4 squared minus 4a is equals to 1 and c equals to 1 over 2a is equals to 1. So this is giving us the first x value being x equal to, basically it will give you the simple set form, of which is 2 plus minus the square root of 3. That means now if we want to compare the intercept, which one goes for a, which one for b, the x of a will be this one of 2, because they say leave your answer in set form. It will be 2 minus square root 3. And then the x of c, it will be 2 plus square root of 3, because it's bigger than a. And then from here now, grade 12, we can now determine the length of BC. BC, remember here we have 2 plus square root of 3. So BC is when you take the value of x here minus the value of x there. So that means it will be 2 plus square root of 3 minus 2. So it will be 2 minus 2, 0. Therefore, BC is equal to the square root of 3. That is the length of BC in said form. Okay. And then from here, hence, determine the coordinates of D and E, of which these are the stationary point. Turning point of H at X is equal to x cubed. Remember, P is minus 6x squared plus 9x minus 2. So if you are looking at the stationary point, you need to derive this. That is 3 times coefficient 3x squared. I know grade 12, you are now familiar with this. 2 times minus 6 minus 12x plus 9. Let it equal to 0 and divide by 3 throughout. That is x squared minus 4x plus 3. Factors of 3, when you add them, they give you minus 4. That is x minus 3 and x minus 1. Therefore, the x value is 3, or another x value equals to 1. To get the y values for this x turning point, we are going to substitute the 3 into the original equation, grade 12. And then if you substitute that, you end up with the y equal to 2. You can do it on your calculator, it's fine, and give us the solution. And then for x equals to 1, y is equals to 2. And then for x equal to 3, y is equal to a minus 2 there. So if we write this in coordinate form, you'll be having 3 and minus 2, and then you are having 1 and 2 there. Remember, I said to you, you can determine the maximum and the minimum turning point, right? And then now by comparing the x and y values, this one is bigger, that means it's maximum, this one is minimum. Now we can tell which one is for D and which one is for the E now. Which one is for D, grade 12, where y is positive and maximum, that means this is D, and this one will be the turning point of E. And then now hence write down the values of x, for which h at x, when you multiply it with its derivative, it will be greater than 0, meaning we are looking for the positive product there. So they must either be both positive or both negative, right? Original graph plus its derivative. Let's start original. Original, above the x-axis, the graph is positive. For original test, né? Above is positive. Below, negative. Below, the graph is negative. We are avoiding the stationary point. Okay. And then gradient increase is positive. The increasing part is positive. The decreasing part is negative. And the increasing part is positive. Now we are going to identify grade 12 where we have plus plus or a minus minus. Okay, we can't take this here. Can you see it's a plus and minus? We can't. We need same signs, right? We start having the same from here. Can you see now? We have positive by positive here. That is between this A value here, which is 2 minus square root 3, with your turning point D. We said that D is taking 1 here. It's 1 and 2 there. So now the first answer will be between the x value of A, which is 2 minus square root 3, with the x value of D, which is 1. That is the first point where we are having an interval that is giving us a positive product. Then we continue. We can't take here because it's a positive times a negative. But just immediately after B here, we now have a negative times a negative up to the stationary point E. At point E, our x is equal to 3 there. So that means it's from 2 up to 3. That is our next x value there. Between 2 and 3. And then now we continue testing grade 12. We can't take this one because it's a negative by positive. Our solution will be here, starting from this point, because we're now starting a plus plus there. And then continuously up to infinity. That means a C value here is 2 plus square root 3. The last answer will be at x greater than 2 plus square root of 3. So that is the first answer, second and third. The 3 marks, therefore they are allocating 1 for each there. And then now we move to the rate of change. With the rate of change now, we are applying our physical science or the technical science, where we are looking at the velocities, the rate of change, the acceleration, and so forth. And then now, in this case, we are given the movement of a ball from a parabolic path given by the equation h at x equal to that, where h is the height in meters and t is the time in seconds. Determine the initial height of the ball above the ground. Initial, before any movement, that ball was at rest. That is your physical science, technical science. If it is at rest, there is no movement. That means the time is still 0 there. So if we put a 0 for time, this will be 0, this will be 0. Therefore, the distance of the ball at 0, it will be 1,62 meters. That is why we have 1 mark there. And then the next one, determine the derivative of that. We are deriving this formula, that is h derivative of t, and then that is minus 2t plus 6. 1 mark for both. It can also be 2 marks. It depends on the examiner. It can worth up to 2 marks, grade 12. And then now hence calculate the maximum height of the ball. The maximum height of the ball. Remember, we are having a derivative of this ball, that at maximum the formula will be h at t minus 2t plus 6. And then if we need the maximum height, is like the maximum turning point of your graph. We are applying exactly that. We let this equal to 0 minus 2t plus 6. Minus 2t to the left, positive 2t, equal to 6 divided by 3, then t is equal to 3. Up to this far, we have just calculated time at maximum, but we are looking for maximum height. Same method, we are going to substitute this t into original. You remember when you are doing stationary point, to find the y value, substitute into original. We are doing the same, grade 12, h at 3 into original minus 3 squared plus 6, 3 plus 1,62. And then this will be our maximum height of the ball that can reach, which give us 10,62 meters. That is the height of the ball. So it's 2 marks for derivative equal to 0, finding your time, substituting time, and finding the answer there. And then 3.4, determine the height of the ball above the ground when it reaches a velocity or a rate of change of which is equal to 3. If we talk rate of change, we are talking the derivative. So now what is the derivative? Minus 2t plus 6. If it reaches a maximum of 3 now, okay, so that will be minus 2 is equal to 3 minus 6, which is minus 3. Then it will be at t equal to 1,5 seconds. Determine the height. We are not yet at the answer, grade 12. We have just calculated the time at that height after when using the velocity of 3 meters per second, the speed or the velocity of 3 meters per second. So we are going to take the h to find h at x formula to find the maximum, the height at that rate of change. Then it will be height at 1,5 minus 1,5 squared plus 6 into 1,5 plus 1,62. We are substituting this time into our equation, and this is giving us 8,37 meters, grade 12. So that is the, if the ball moves at the speed of the speed of 3 meters per second for 1,5 seconds, it will reach the height of 8,37. So these are the questions that you find at the end of your differential calculus. Then we move to integration. And then with integration, remember, you only relate your question to the rule that is suitable for that. If you look at this one, this is an integration, is the same as 5 over x dx. Can we relate this to this? Rules we are having, you can see that is the same as that one. So answer must be what? K ln x with K ln of x plus c. And then what is k? K is the constant value that we are having here. Then the answer will be 5 ln of x plus c. Done, grade 12. Then that is your 2 marks. You just relate your integration with the correct rule and then use the rule. The rules are at the back of your question paper there. And then now we look at this one. If it is written 4, it is actually 4x to the power 0. Do you still remember that? Plus, we are given the 2 to the power minus x. Can you see we have an exponent on the x? The exponent x. We have x on the exponent, grade 12. That means it's this rule. X on the exponent is this rule now. But because it's having a negative here, it will go there. Now let's compare this one. The second one goes with that one, and then 4x to the power 0 goes with the original one, this one. Can you see that? Now you know which rule to use. Okay, for the first one, we are going to use this one. It says leave the constant value. We leave 4. And then now from the x, create a fraction. It will be multiply by x 0 plus 1 over 0 plus 1. Same exponent, right? Plus, we are on this one now. It says this one, take k, write k. Okay, our k is 2. And then now on top we are having a to the power nx. Okay, we do not have a k there. It will be 2 to the power minus x, and then below we are having the n. N in this case is coefficient of x, that means it's minus 1, ln of a plus c. So it will be final answer for x, because this one is x to the power 1 over 1, which is x to the power 1, plus 2 to the power minus x, and then that ln is minus ln a plus c. So it will be 1 mark and 2 marks. If you ignore a c, you will be penalized for not putting a c. Remember, you will be penalized 1 for notation throughout your question paper. And then now the next question here, we cannot, same as derivative, we cannot integrate with the denominator there. We are going to divide throughout by that denominator. 2x into 8x, it will be 4x to the power 3. And then 2x into that one, it will be minus half, and then x to the power 1. Okay, and then that is in terms of dx. Right, and then now we relate to integration, that is rule number 1. And then this is also rule number 1. So your answer will be what, grade 12? 4 constant, and then it's x to the power 3 plus 1, 3 plus 1. And then this one minus half, multiply constant, okay, x 1 plus 1, 1 plus 1. And then remember your plus c, that is 4, multiply by x to the power 4 over 4, minus half, multiply by x squared over 2, plus c. The 4 will cancel a 4, you are left with x to the power 4. And then the half times x squared over 2 is minus x squared over 4 plus c. Then it's 1, 2, 3 marks, grade 12 for that particular problem. And then our last question now is on sketch. The sketch shows function g defined by g at x equal to an exponential function. The shaded area bounded by the curve of g and the x-axis between x minus 1 here and the x equal to 3. As you can see, it is bounded within those x values. It's minus 1 and 3. So this is the shaded area there, okay? Now we want to calculate the area of that shaded region, okay? Shaded region below the curve there. And then now our shaded region will be the integration from where? The maximum value to the minimum value of which equation? 2 to the power x plus 2. Do you still remember that, grade 12? And then now we are going to use a square bracket to indicate the integrated value, still from 3 to minus 1. We are integrating 2 to the power x. Our answer will be 2 to the power x over the ln of 2. The ln of 2 there, okay? And then now this one, remember, is that one of x to the power 0. It will be 2x to the power 1 for the integration of that. We can now substitute. Do you still remember 2 brackets of the same thing, minusing another one, but they must exactly be the same. So if substituting a 3, 2 to the power 3 ln of 2 plus 2 into 3 minus 2 to the power minus 1 ln of 2 plus 2 into minus 1. And then if you put this into your calculator, you end up with 18,82 square units. So that is basically the area that we are looking for. And then it's 1 mark for your integral for substitution 2, 3, and then final answer for that one. And the notation there for writing this in integral form. So this is worth 6 marks. Thank you very much, grade 12. This brings us to the end of today's lesson. And this lesson was brought to you by the Gauteng Department of Education in collaboration with Saibodo Discovery Center. See you next time. Bye.